Data structure is the science of storing and managing data. In this lesson, we will learn 3 fundamental data structure concepts: queue, stack, and heap. These 3 concepts are metaphors for describing 3 different ways to store and manage data and tasks in memory. Queue follows the FIFO principle. FIFO means first in, first out. If we put a series of tasks in a queue, the first task in the queue will be executed first. You can think of a queue as a barrel, and each task a bullet. The first bullet entering the barrel will be fired first. Adding a new task into a queue is called enqueue. Taking a task out of a queue is called dequeue. A queue will keep 2 pointers, the front pointer and the rear pointer. The front pointer points to the first task in the queue. In other words, the task pointed by the front pointer will be executed first. The rear pointer points to the last task in the queue, which is also the last task that will be executed. With a stack, things work in the opposite direction. It follows the LIFO principle, last in, first out. The first task in the stack will be executed last, and the last task entering the stack will be executed first. We use the term frame to refer to stack tasks. You can think of a stack as a magazine. Each task, or frame, is a bullet. The last bullet we put into the magazine will be fired first. Adding a new task into the stack is called push. Moving a task out of a stack is called pop. The bottom of the stack is fixed, so we only need 1 pointer to manage it. We call that pointer the top pointer, and it points to the last element added into the stack. In other words, the task pointed by the top pointer will be executed first. Queue and stack are used together to achieve the best program efficiency. For now, just remember stack is the area where tasks are executed and completed. Queue helps stack manage unexecuted tasks. You will learn more about this later. Heap is an area of memory where elements are stored and removed in any order. So unlike queue and stack, heap is unordered. As a result, we never manage tasks using heap. Having no order gives heap lots of flexibility in terms of data storage. We use heap to store objects, as their sizes are often unpredictable. In stack, we can access objects via their memory address. How stack, queue, and heap work is actually a rather complicated topic. Frankly speaking, as a JS developer, there is no need to dig deep in this area. In lower-level languages like C, you need to manage memory space manually, including allocating memory space using malloc and releasing memory space using free. But in JS, you don't need to do this yourself. The JS engine does it for you. To save your time, we only explained the 3 concepts in a simplified way. But if you want to learn more about data structure, we recommend you learn a lower-level language first.